Okay, so right now we're going to graph some functions. We're going to graph with something called an exponential function. So an exponential function, it's called that just because each of these functions has has an exponent in it, and the exponent is one of the variables. It's the input variable, the x coordinate. So we're going to start off by choosing some points. So the whole idea on this, when we graph this, is that we are going to we're just trying to plot some points and get an idea of where what that graph looks like, the shape of the graph. Now, one of the key points that we want to be sure to include is the y-intercept. So we're going to find that. That's going to be your initial value. So I'm going to put that here. And that's going to be where 0 is, right? When x is equal to 0. And it's a good idea to pick values on both sides of that point. So on one side of that point, I have the negative numbers. And sometimes, I might want to start with -2, -1, 0. But in this case, I'm just going to start with -1. So -1, 0, 1, 2, and 3. So now at this point, it's just all about the calculator and using the calculator. So I'm going to turn the calculator on, and we're going to put this into this equation. So just like any other problem when we're evaluating, we're going to plug in. So the x is right here. So wherever the x is, if there's more than one, you put it in more than one spot. Here it's only one place. You're going to replace that with the x coordinate. The keystrokes on that are, for most scientific calculators, they're basically the same. The only difference is the exponent key. So we're going to, in this one, it's going to be 4 times 3 to the -1 power. So it's going to be 4 times, these are the keystrokes, 4 times 3, and then there's an exponent key, which is that one right there. Some calculators have an exponent key that looks more like that. Y to the x, x to the y, a to the b, something along those lines. But this calculator uses that. So we're going to do that, and then we have to turn it into a -1. You do not use the subtraction symbol. In this case, you use this changes it from a positive to a negative, or a negative to a positive. We're not using this one. So it'll be that. So then we use the negative sign, the number 1, and then the equals. So those are the keystrokes. So it's going to be 4 times 3, exponent key, -1 equals. And we end up with 1.3333. And we're going to round that off to 1.3. Now notice that's a positive number. Even though this was a negative here, we end up with a positive here. So I'm going to call that 1.3. We round that off. The next one would be the same thing. 4 times 3, exponent. Now we no longer need a negative for this one, so we don't use that negative key. It's just 0 and then equals. So clear it. 4 times 3, exponent 0 equals. And we should end up with 4. Now hopefully that makes sense, because remember 3 to the 0 power is 1. So this is just 4 times 1. This part right here is equal to 1, which gives you 4. The next one will be 4 times 3 to the first power, and that should be 12. 4 times 3, exponent key 1 equals 12. And here, 4 times 3 to the second power. And that's 36. 4 times 3 to the third power. And we end up with 108. Okay, so now we're going to plot these points. Now notice -1. So this on the vertical scale we're counting by twos. So 0, 2, 4, 6. So 1 is halfway between. If we look at this 1.3, that's going to be between 1 and 2. So we go to the left one, halfway up, and then a little bit more. Now when you have decimals or fractions like this, then you need to estimate it. And it doesn't have to be perfect. All we're trying to get is a general idea of what it looks like. So here we have -1, 1.3. And we have 0, 4. So 0 up to here, that's 4. 1, 12. And here we go for that one. Now notice we only have 3 points here. We could probably leave it a little. We can't use this one because 2 goes way up here off the scale. So we're not going to use that. We're not going to use this. But what I am going to do is I'm going to go back up here and I'm going to use -2. So now 4 times 3 to the -2 power equals, let's see what we get. 4 times 3 exponent -2 equals, and we have 0.4444. Now, where that is going to be somewhere a little bit less than half. So I go 1, 2, and a little bit less than half. It's going to be somewhere around here. It doesn't have to be perfect, but now that gives me a better idea what that curve looks like. So it goes like that. Now on these graphs, it's never going to cross over the x-axis. So don't draw it down here. Go like that, and then as it's going to get closer and closer and closer, but never quite touch it. And then that's going to go straight up, or not straight up, but it'll curve, but it'll get steeper and steeper and steeper. And that's what the curve looks like. So now let's take a look at a different one. So on this one, notice this value right here is a decimal. This one's a whole number, right? An integer 3. This is 0.3. So this one's going to behave a little bit differently, but the method will be exactly the same. So I'm going to go ahead and start off with -2. Many times when you have a decimal like this, you want to start off with a slightly larger absolute value on the negatives. But when you calculate it, if you get a number that's too big or too small, then you can adjust the numbers you pick. So -1, 2, -1, 0, 1. Okay, so let's take a look at it and see what we have. 5 times 0.3 to the -2. Let's see what we get. 5 times. Now you don't need to put the 0 there. Okay, you can if you want. You can do it 0.3, or you can do it as just 0.3. It doesn't matter. -2, and we get 55.5. Now, as you can see, that one's going to be way too big, so we're not going to use that. So hopefully that one will work better. So now we're going to do 5 times 0.3. Okay, so notice last time I used 0.3. This time I'm just going to use 0.3. The 0 is a placeholder. Okay, so what do we have? I put in 5 times 0.3, exponent key -1, and we end up with 16.6. So it's still a pretty big number, isn't it? 16.6666. I'm going to round that off to 0.7. Okay? Now, the next one is 5 times 0.3 to the 0 power. That's going to be 1, right? So 5 times 1 will give you 5. And if you're still not comfortable with that, 5 times 0.3, 0, 1, and there you have your 5. And then the last one is 5 times 0.3 to the first power, and that's 1.5. And let's do one more, 2. So 5 times 0.3 exponent 2, and you end up with 0.45. Now 0.45 is actually pretty close to 0.5. It's about halfway. So when we plot these points, like I said, this is too big. It goes way off the scale. We can't graph that unless we change our graph, and we're not going to right now. So we just want to plot the points that'll give us a good idea what it looks like. So we go -1, 16.7. Now that would be 17, so it's going to be somewhere below 17. And so I'm going to put it right about here. And we have 0, 5, 4, 5, halfway between, over 1. There's 1, halfway between, 1.5, and then 5. Oh, I'm sorry. That's 1, right? Okay, so then 2.5, 0.45, which is a little bit less than 0.5. It's going to look something like that. So now, just draw your curve as well as you can. And that's not perfect, but it doesn't have to be perfect. And there you have your curve. It looks something like that. So notice they both look the same in terms of the general shape, but they're kind of mirror images, right? If you flip this one over, okay, that's what it looks like. So notice this value right here. Whenever you have a value that is between 0 and 1, okay, so in between 0 and 1, then it's going to be going downhill to the right. If this number right here, the base of where the exponent is, if that's larger than 1, then it's going to be going up to the right. So between 0 and 1, down to the right. Greater than 1, up to the right.